graphing y equals cotangent or cot, open bracket, pi over 4x plus 3 pi over 4, close bracket. The general cotangent function equation is y equals a cotan, open bracket, bx minus c, close bracket, plus d. So it's good to know what the graph of tangents look like, or even if you know what the graph of cotangent looks like. But in order to produce graph of cotangent, I'm producing the graph of tangent. The tangent goes from minus pi over 2 to pi. It has a period of 1 pi, and it goes from the negative infinity to 0 there, and then goes all the way to positive infinity. So that's what the graph of tangent looks like. Now, to draw the graph of cotangent, that's what I'm going to do next. Right, to draw the graph of cotangent, cotangent has a relationship with tangent, and the relationship is cotangent. That means complement of tangent. Cotangent of x is equal to 1 over tangent of x. So the relationship is a reciprocal. It's an inverse relationship. Therefore, when tan is 0, cotangent is 1 over 0. And 1 over 0 is what we called, it's undefined, it's a line of asymptote. So that means that when x equals to 0, that's the line of asymptote for cotangent, because writing 1 over 0 is what we called infinity. And at the same time, 1 over infinity is what we called 0. So those are the two important things here. And you can see here, this is the infinity line for cotangent, and this is where this is infinity at pi over 2, therefore it's going to be 0 for pi, for cotangent. So that'll be 0 for cotangent, and so that means cotangent will go through that line, and likewise it will go through that line because it's 1 over infinity, which is 0. And that's why we draw the line of infinity here for cotangent. So that's the line of asymptote, which means that the graph will come through, so it's going to come from there, goes through 0, and then go to pi. Pi is, the tangent goes through pi here, because if I draw tangent, it goes from negative infinity all the way to pi. So that meant that if it goes through pi, it has to go through infinity here for cotangent. So now that's the line of infinity for cotangent. And that point is pi, because 1 over 0 is infinity. So when we draw in cotangent, it comes from here. So that's cotangent. This is pi over 2, so that's 1 over infinity. 1 over infinity is here. So now the next line of asymptote is pi. So this is pi over 2 minus pi over 2, and this is pi minus pi. So the next line of asymptote is here. just draw that. So that's the line of asymptote there, which means the curve will be coming from here again for cotangent all the way to there. Oops, excusez-moi. All the way to there, and then goes all the way to negative infinity. So that's a line for cotangent. There we go, all the way to negative infinity. Now, and this is one period. Each period is a pi. Likewise, for tan, that is a period here. So period is minus pi over 2 to pi over 2. For cotangent is from 0 to pi. That's where, and the line of asymptote is the hidden line. So that's written as line of asymptote. That's the line the curve never touches, but approaches but never touch. Right, now we can then use this idea to then plot the graph of cotan with a phase difference and a expansion or compression. First is the amplitude. Well, cotan and tan don't have amplitude because they have infinite y values, both in the positive and negative direction, so there's no cap. So none. Number 2 is period. Well, tan, cotangent, complement of tangent, and tan have the period of pi, because every period is a pi, and then you divide that by b. The value of b is, this is b here, next to x, so that will be b here. So you have to divide that by b. In this case, so it's going to be pi divided by pi over 4. And then, since we're dividing pi by pi over 4, we're going to get pi times 4 over pi. Because if you're dividing by something, then it's going to be reciprocal times 1 over that thing. So you can flip it and then you turn it into times. So that's where you're going to get pi cancel pi, and then you get, in this case, the period will be 4. So that's what the period is for. So number 3. Number 3 is going to be x scale. So the x scale is going to be period over, because you've got 2, in every period, you got 2 lines of asymptote. So you divide it by 2. And that will give, period is 4, we just got 4, and divide it by 2, and that will be 2. So that means we're going to be adding 2 every time. Number 4, we want to work out the start, the phase shift. In the phase shift, we want to work out the start and the end. Now, the start is when, if you look at cotan, the start is at the line of asymptote here. We set cotan to x to 0, you get line of asymptote. Well, the start is, if we set the bracket, the function, if we don't have x, we've got pi x over 4 plus 3 pi over 4. So we have to set that to 0. So we pi x over 4 plus 3 pi over 4 equal to 0, which means we would have, well, pi x over 4 equals to minus 3 pi over 4. 4 cancels 4, pi cancels pi, because it's on the both side and there's nothing else attached to them, and therefore x equals 3. x equals minus 3. So we're going to start at minus 3, and that will be the line of asymptote. The end is going to be, you set that to pi, because that's where the second line of asymptote is. You can pick any of this line if you want to set it up, but we're using that one. So you're going to, for the end, you're going to get pi x over 4 plus 3 pi over 4 equals pi. So you take that to the other side, and you're going to get pi x over 4 equals pi minus 3 pi over 4. If we make them the same denominator, that's pi over 1, so that'll be 4 pi over 4, right? 4 pi over 4 minus 3 pi over 4 is going to be pi over 4. So that's 4 times, this is over 1, times it by 4, times that by 4. So 4 pi over 4 minus 3 pi over 4, that's pi over 4. Okay, so that means you got pi over x pi over 4 here. Pi over 4 cancels pi over 4, x equals 1. So that meant x equals 1. So that's the first line of asymptote, second line of asymptote, and that's all we need to plot. As you can see, this is now ready to plot, but the scale is different because we have divided the b by c here, because that's the phase shift here. So when we work it out, our phase shift is actually, the pi has cancelled that pi, so therefore in our x-axis we're not going to have any pi's, because there's a pi here and there's a pi here, and they both cancel out because we set them to 0, right? So they will cancel out. So now we just have numbers, and so what we start from 0. The line of asymptotes is minus 3, that's the start. So that's what we need to do first, is to draw the line of asymptote, because it tells us what to do. Minus 3, so just draw your line of asymptote. That's equivalent to the line of asymptote here. That's why we set it to 0. Okay, and also the second line of asymptote is 1. Again, that's why we set that to pi, because that's the second line of asymptote, so it's pi. So we set it to pi. Right, now the curve is going to be going through halfway between, because you can see here that's halfway between is that. So halfway between this is where the curve is going to go in through. So my halfway is here. So it'll be crossing at minus 1. And we know there's a shift there, because minus 2, minus 3, add, this is a scale now. If you add 2 to minus 3, you get minus 1. So that scale tells you that as well. It says add 2 to minus 3, you get minus 1. So the curve should be coming from there all the way, right? And then going through there. So that's the function there. But so that means the next one will be from 1, because if you look, the period is 4. So the next one will be 5, because you need 1, 2, 3, 4. So next period will be here, 5. So yes, it truly tells you what to do, to be honest. And that's 5. Again, so you're going to have to add 2 to that to go to the next. So you add 2 to 1, that will be 3. So the next intersection is 3 here. And the curve will be coming in from there, through there, and through the line of approaching the line of asymptote. So that should be approaching the line of asymptote, and that's your diagram there. So that goes all the way to infinity y, positive infinity, that goes to negative infinity, and that's the sketch of the graph. So this is for y equals cot pi x over 4 plus 3 pi over 4. The point number 5 that I didn't check with is the vertical translation. In this case, this is plus 0 because that's d here. D is the vertical translation. There's horizontal translation, we saw that. But the vertical translation is plus 0, but we don't have that, so that's just 0, which means y equal to 0, which means the curve is going to lie on y equal to 0. So this is y equal to 0, that line, and that's the x-axis. So that's y equal to 0. Likewise, when we did a cotangent graph, that's plus 0. That's why it's on y equal to 0. And tangent as well is plus 0. So that's why this is y equal to 0. If that was 1, that curve would be sitting on 1. That curve here would be sitting on 1, not y equal to 0. If that was minus 1, it would be sitting on minus 1. And that's how you sketch the curve of a cotangent function.